Hello friends, subscribers and new viewers of this channel, and welcome to FPGA tutorials. In this tutorial, we explain how to create a test bench and simulate a Verilog FPGA program for Xilinx AMD boards in the Vivado development environment. To keep the presentation as simple as possible, we will implement and/or gates, and we will simulate them. By the end of this tutorial, you will learn how to implement this module that implements and/or gates. Then you will learn how to write a test bench file that simulates this module under different scenarios. And finally, you will learn how to run the simulation shown over here. In this simulation, you can use this slider to check different conditions and to check the outputs. Briefly speaking, we have two inputs, input 1 and input 2. Input 1 and input 2 are the inputs of the AND gate, and the output of the AND gate is output 1 shown over here. Then input 1 and input 2 are at the same time inputs of the OR gate, whose output is output 2. When I move this slider, you will see how the inputs and outputs change. For example, initially, both inputs are 0, and we can see that AND gate produces 0 and OR gate produces 0. Then if I move the slider, we can see that input 2 switches to 1. We can see that AND gate output is 0, however, the output of OR gate becomes 1. And we can move through different scenarios, and we can make sure that these gates are properly implemented. Although this example might look simple, it is very important. In its essence, this example contains all the steps that you need to perform in order to implement and simulate your design. But before we start with explanations and with coding, we need to provide an answer to this very important question. Namely, some of you might ask me the following question: why do I need to simulate my FPGA program and my FPGA design? Well, there are several reasons for doing that, and here are some reasons. First of all, simulation saves significant amount of time and it enables you to debug your code. Then, before you synthesize and implement your design, you need to test your code under different scenarios and under different initial conditions. Then, simulation can reveal errors and it can provide insights in how your design will behave in practice. And finally, to properly design a simulation scenario, you still need to understand your hardware constraints, delays, and some other parameters of your design. As mentioned previously, in this video tutorial, we will implement and/or gates. Here are the truth tables of and/or gates. Let's start with the AND gate. Here we provide two inputs to our AND gate, input 1 and input 2. And over here you can see the output. When both input 1 and input 2 are 0, the output is 0. When input 1 is 0, input 2 is 1, we have 0. When input 1 is 0, input 2 is 0, the AND gate will produce 0, and finally when both inputs are equal to 1, then the output of the AND gate produces 1. Let's analyze the OR gates. First of all, when both inputs are 0, the output of the OR gate is 0. When input 1 is 0 and input 2 is 1, then the output is 1. Then when input 1 is 1, input 2 is 0, the output is 1, and when both inputs are 1, the output of the OR gate is 1. Over here you can see the timing diagram of our simulation. And this timing diagram will enable you to confirm this truth table and to make sure that your implementation works as it should work. Let's start with implementation. First of all, let's click on Start and search for Vivado and click over here. As you can observe over here, I'm running Vivado 2024 0.1. However, you can also use any other version. Also, in this video tutorial, you actually don't need an FPGA. This is mainly because we will run a simulation. So let's create our first project. Click here to create a project, then click on Next. Let's keep these default settings, click on Next. Select RTL project, click on Next. And over here, you actually don't need to select any particular board. You can go with any board you like. However, I like to select a board that I always use. So I will click on boards and I will search Nexus A7. Here it is. I will select it and click on Next. And over here, click on Finish. The first step is to write a module that will implement and/or gates. Okay, so to do that, over here, locate the sources window, then expand over here, click on Design Sources, and then click over here, Add Sources. Then over here, select Add or Create Design Sources, click on Next, click on Create File, and let's call the file basic_gate. And click OK. And click on Finish. Click on OK once again, and yes. Here it is. Now be patient over here. If you expand now Design Sources folder, you will see our file. So double click on this file, expand this window, and let's start editing this file. First of all, let's erase these comments in order to keep this file as clean as possible. In this video tutorial, I assume that you either are complete beginners or you know very little about FPGAs and Verilog. Consequently, I will spend an additional time explaining basic things. Over here, we will define our module that will govern the behavior of our program. Roughly speaking, modules can be seen as functions. Over here, we need to provide inputs and outputs to our module. So let's type input 1, input 2, these will be the inputs, then we'll have output 1 and output 2. Okay, now, over here, we just provided the parameters. However, Verilog doesn't know if input 1 is actually an input or maybe output 1 is an input. Consequently, we need to declare inputs and outputs. I usually like to write comments in my code, and I suggest to everyone to do that. So let's type over here, declare inputs and outputs. By writing comments, you will make your code more readable. So to declare an input, we need to use the keyword input. And over here, we need to specify that the inputs will be input 1 and input 2. So let's type this. Let's end the line with a semicolon. Then we need to declare outputs. Outputs will be, or output, be careful here, it's not a plural, it's a singular output. Outputs will be output 1 and output 2. And add semicolon. Okay, so these are the inputs and outputs. Next, we need to implement our gates. Over here, let's implement AND gate. We simply say assign, this is a keyword. Then we need to say output 1 is equal to input 1, and then we need to introduce a logical AND. Here's how we type it, input 2. Here it is, and don't forget the semicolon. Over here we are saying assign to the output input 1 and input 2. Okay, let's implement our OR gate. So again, we use the assign statement, assign, then we say output 2 is assigned to input 1, and let's use OR. In Verilog, OR symbol is this. And then we need to specify input 2, and then semicolon. And that's it. This is our first module that implements AND and OR gates. Let's save this module and let's continue. The next step is to create a test bench file that will be used to simulate this module. To do that, go to Sources menu, then click over here on Simulation Sources, do the right click and click on Add Sources. Then make sure that Add or Create Simulation Sources is selected, click on Next, over here click on Create File, and let's call the file as Test Bench Module. Okay, and let's click OK, and let's click on Finish, and click OK and Yes, and wait for a while. So, where is our file? Now, if you click on Simulation Sources and if you expand over here, you will see our file. So double click over here and let's expand this window and let's start editing the file. First of all, let's erase these comments. Over here, a timescale is defined. A timescale defines a unit that's later on used to introduce delays. In this case, the unit is 1 nanosecond. Consequently, later on you will see that we will wait for example, 100. This means that we will wait for 100 nanoseconds. Then, let's erase this parentheses over here since we don't need them. And let's continue. The first step is to declare inputs and outputs that should match the inputs and outputs in the original module. So let's go back to basic gate module and let's see what are the inputs. We have input 1 and input 2, which are the inputs, and we have two outputs, output 1 and output 2. Consequently, over here, we need to declare the corresponding variables. Declare inputs and outputs for our simulation. Now, let's start with inputs. Inputs should be declared as registers. This is because we want to sweep through the truth table of the AND and NOR gates, and consequently the order matters. Namely, we start from 0, 0, then we go to 0, 1, 1, 0, and 1, 1. To achieve this change, we need to remember the previous values of input 1 and input 2. That's why we will declare input 1 and input 2 as registers. And I will call them as input 1, then I will introduce t, such that these variables are different from the variables over here. This is not completely necessary, however, I like to do that. T is test bench, so whenever you see t after variable, you know that that's a test bench or simulation variable. So let's do the same thing for the input 2. And let's end the statement with a semicolon. Next, we need to declare outputs. Over here, outputs don't need to be declared as registers. Consequently, we can simply use var. So let's type var, and let's type again output 1t, which will correspond to output 1, and output 2t, which corresponds to output 2 in our module. Okay, let's save this file by pressing Ctrl S. The next step is to connect input 1t, input 2t, output 1t, and output 2t with the corresponding variables inside of our module. To do that, we need to define a unit under test. Let's see how we do that. First of all, let's go to our basic gate and let's copy this module name. And we start the statement with the module name. Then I will call my unit under test simply as UUT, which stands for unit under test. And over here we need to make connections. So let's add parentheses and add semicolon. And let's start defining connections. Input 1 should be connected to input 1t. So let's type it here. Input, we have to start actually with a dot. So the connection starts with a dot, input 1, then in parentheses, we need to say input 1t. This means that now input 1 is linked to input 1t. Then let's do the same thing for input 2. Input 2 should be linked to input 2t. Then output 1 from our module, that is this variable, should be linked to the output 1t. And finally, let me just correct here and copy this. Output 2 should be linked to the output 2t. And let's erase this comma over here. The next step is to properly define and set up our simulation. So let's start. We start with initial begin. That is, we are starting our simulation. After this statement, we need to initialize our variables. We will initialize both input 1t and input 2t registers as zeros. So let's type input 1t is equal to 0 and input 2t is also equal to 0. That is, at the beginning of simulation, input 1 and input 2 are set to 0. And this is a necessary step since over here we just declared registers without specifying the values. And we need to specify the start values, otherwise our simulation will not be defined. Then we need to wait for some time. That is, we need to introduce a delay. We introduce a delay like this, and we type the amount of delay. Over here, it's 100. However, what are the units? Well, if we go all the way up, we can see that the unit is 1 nanosecond. Consequently, over here, we are delaying the code for 100 nanoseconds. Next, we need to simulate. So let's type a comment here. We simulate. But before we actually implement the simulation, let's go back and let's analyze our truth table. The simulation should sweep through the rows of our truth table. So how to achieve that? That is, how to make proper transitions such that we go from 0, 0 to 0, 1, then to 1, 0, and finally to 1, 1. Let's learn how to do that. To do that, first of all, we need to use a for loop. Or there is another way, and that is more elegant way that I will use in this tutorial, and that is to use repeat. And over here, as an argument of repeat, we need to specify how many times we want to repeat this code block. Over here, I will repeat 8 times. So this thing will mean that I will sweep twice through this truth table. That is, my simulation will repeat twice, and every time I will go back to the initial values. Now, we need to make a transition. To make a transition, we need to use this statement. First of all, we will start the statement with a delay, and I will explain the purpose of this delay once I finish the statement. Then, I'm going to use a concatenation operator to combine input 1t and input 2t. So let me type it here, like this. I'm using curly braces. In this way, I created a pair of bits. That is, I created these 2 bits over here. Then I'm saying the next values of input 1t and input 2t are equal to the previous values plus over here I need to add this constant, which is basically 1 bit, and then semicolon. So what's happening over here? This statement on the right hand side will take the current values of input 1t and input 2t, then it will add over here 1 bit, and this 1 bit will make a transition from one cell to another. That is, if we are at 0, 0, the next value of the pair will be 0, 1, etc. Next, if I go back, this value on the right hand side will not immediately be assigned to this value of the left hand side. It will be assigned after 100 nanoseconds. So why this delay is introduced? This delay is introduced to keep the current values of input 1t and input 2t for some time, such that our logical circuit can react and such that we can nicely see the transitions. And this is how we do it. And this will actually create a train of pulses, as you will see later on, and this will enable us to simulate our design. After this, we need to end everything by typing end. And that's it. Simple as that. Before I run this simulation, I need to explain several things. First of all, over here, I didn't add begin after repeat. This is mainly because I have a single statement after repeat. However, I can also add begin. So I can type begin over here. However, after every begin, I need to add an additional end. So I can also type this. And let's leave it like this. And let me put it like this. So we have here begin, end, and over here I can just put this begin after initial. That it really doesn't matter. Okay, so let's keep the code like this. Let's save the code and let's run this simulation. Okay, to run this simulation, locate under Project Manager Simulation, expand Simulation, and click on Run Simulation. Then click on Run Behavioral Simulation, and now the simulation is being executed, compiled, and let's see the output. Okay, so let's see what happened over here. This is our time diagram. So let's expand this window, put it down, and now if you scroll all the way left, you will see that something is changing over here. However, you can see that this graph is zoomed too much. You need to zoom out. There are several ways to zoom out. You can either press here many times, or you can use the middle mouse button and control. Namely, if you press the control key and hold control key, and if you use your middle mouse button, and if you scroll forward or backward, you can zoom in or zoom out. So let's keep it like this. And let's analyze what's happening over here. The first thing that you should notice is that there is this slider over here. And as you move this slider left or right, over here you can see that the values will be changing. The first row is the value of 1t, that is the value of input 1. The second one is the value of input 2. The third one is output 1, and the fourth one is output 2. And you can see over here the timing and how the values are being changed from 0 to 1. So let's start with the initial case. That is, let's see what's happening over here. Since we have a delay in our code, the simulation will start after 100 nanoseconds. That is, we are setting initial values, and we start 0, 0 for both inputs, and we can see that both AND and NOR gates are 0, and that's correct. Then let's see what's happening here. Now, input 2 changed, right? It switched. And we can see that AND gate, as expected, is 0, and OR gate, as expected, produces 1. Perfect. So we go further. Now over here, input 1 switches, and input 2 goes back to 0. This is this transition over here, the first transition. And as expected, the output of the AND gate is 0, and the output of the OR gate is 1. Now we move forward, 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 forward. Now what happens, we make the last transition. That is this transition over here. And let's see what happens over here. We can see that both inputs are 1, and as expected, the output of AND gate is 1, and the output of OR gate is also 1, and this is correct. Over here, we repeat the simulation. We go back to 0 state, then we again switch input 2, then switch input 1, then switch both of them, and everything works as expected. And in this way, you were able to simulate your first FPGA design. Okay, that's all for today, and thanks for watching.